I'd like to thank Swinban Bhai for inviting me to present this seminar here. Of course, thank you all of you for coming for the seminar during lunchtime, I guess, and I hope all of you had lunch. Okay, so today I'm going to discuss about cloud computing. So I'm going to divide this talk into two sections. First, I will discuss about introduction, what cloud computing is, provide motivation and opportunities and challenges. Then followed by discussing about what we at University of Melbourne doing in this area. So this is the work primarily carried out within our laboratory, Cloud Computing and Distributed System Lab in Department of Computer Science. As Hang said, we have a company called Manjrasoft, which is commercializing some of the innovation that is coming from our lab. But now it is an independent company of its own, and it has got its own people to look after development and promotion of the company. Okay, so this work of course, supported by various organizations, including ERC, Department of Innovation, and companies such as Microsoft and Computer Associates. So before I go deeper into cloud computing, so let me make a little more clear about the difference between a classical model of computing and cloud computing. So a classical model of computing is essentially, so you buy everything that includes infrastructure, hardware, software, and necessary network, and set up yourself a capability within your enterprise or within your university or wherever it is, and then use it. So as a result, this becomes quite expensive. Even small SMEs may not be able to afford to have access to all kinds of software that we need. So and on top of it, as we know, in every 18 months, IT things change. So we get new hardware, new software. As a result, you again have to repeat the cycle. So as a result, the cost of ownership and cost of operation is very, very high. So this is what cloud computing is trying to solve. Essentially, it is trying to make IT as a subscription-oriented services, wherein third party sets up all this for you, and you will simply rent the capability that you need, and when you need it, and how long you need it, and pay for what you consume. As a result, it can be quite inexpensive. So, so therefore, many people can afford. For example, if there is a SME, like for example, Manjrasoft is an SME. If it needs access to, say, CRM software, customer relation management software. So if we try to buy from Oracle, for instance, it would probably cost us at least $50,000. So as a SME, you don't have so much of money to burn on a one small CRM software. What do? You can rent such capability from companies such as Salesforce.com. It would be available for a small price of something like $2,000 per year, or maybe just $200 per month, and you pay as you go. When you have got more, when your customer base increases, you can pay higher price, which is actually the right thing to do. So this is the promise that cloud computing is offering. Essentially offering services on a pay-as-you-go basis, and that also based on the quality that you're expecting, and also based on the amount of capability that you want to use. So keeping this in mind, let's discuss more about what is it, and what are the what are the technical differences, or technical aspect that we need to deal with it to make this vision into reality. So here is the outline. I will give you very briefly vision of computer utilities. Basically look into various developments in IT area that have happened during last 40 years very quickly, and then and discuss how cloud computing is making that vision happen. So that comes to cloud computing. Here I will discuss more about trends and the benefits and the challenges and the potential, business potential of this cloud computing. So then I will discuss about architecture of cloud based on market principles, because this is the IT capability that is offered on a service subscription basis. We need to make sure that it does conform to market principles, and it offers capabilities as per the service level agreements. Then I will discuss about our own efforts at University of Melbourne, Cloud Bus, and one of the software that we commercialize through Manjrasoft. So then I will give you summary and thoughts for the future, because it's an area that is emerging. So there are lots of open issues that one can look at if you like to conduct research in this area. So to begin with this first section, computer utilities vision. So this vision of computer utility, basically delivering computing as utility, has been around. For example, if you look at this statement from a person called Leonard. So he was a chief scientist for a project called ARPANET. This is what he said in 1969. That is 40 years ago. So he said, as of now, computer networks are still their infancy, but when they become mature and sophisticated, we will probably see the spread of computer utilities that will serve homes and offices just like telephone and electric utilities of those days and even present day. So during last 40 years, several advances have taken place in ICT area, both in computing and communication area. So often people treat computing and communication as separate activities, but however now they are more integrated. So these developments are the one which are really turning this vision of computer utilities into reality. So what are those developments during last 40 years that happened? There are many developments in IT area that have making this possible. Some key ones I like to highlight. For example, web started around 18 years ago as a way of providing access to remote information. Since then, there are several developments have occurred in the name of web. For example, web services recently during last 6 years. So web services are essentially enabling a standard way of are providing mechanism for standard way of supporting communication between applications, and in a way they are also contributing. Then like service computing, which is of course a notion, service oriented architecture. So now in IT area, any system that are built, they are following this architecture. So like grid computing. So I myself, I guess, given 2-3 seminars previously on grid computing topic here in this same theater. So grid computing has been around during last 10 years. Several advances have taken place in this area. But however, grid computing was very much restricted to scientific and research application. Where the focus is on how do we provide a cyber infrastructure or an IT infrastructure that enable collaborative research between multiple scientists from different locations. For example, a scientist located here in Swinburne, say working in astronomy, and scientist located in Melbourne University, maybe astronomy or some other, they all work together to share telescope, to share data set, to share analysis and share IT equipment, and then perform collaborative research. So this is what grid computing really provided a cyber infrastructure that enable collaborative scientific research. And it of course continue to progress, and more applications are being created. So here in Australia there were a number of initiatives in this area, and right now there is some initiative as part of this increased e-research initiative, nationwide initiative providing infrastructure for various applications. So this is going on, but still focus on research applications. So coming to, for example, cloud computing. Cloud computing has certain departure from that focus to commercial and consumer applications. So this is a wild and a very innovative thinking in terms of providing capabilities that are essential for consumer and commercial applications. And in between we have seen things like peer-to-peer computing, for example. So peer-to-peer computing was most popularly known for providing an infrastructure that enable large-scale sharing of music files in a decentralized manner. There was hardly any control. So you can share in an open manner, and there were problems like copyright infringement and so on. But however, it provides very important fundamental principles essential for building scalable networks. So, so in my opinion, each one of these have made good progress, but not one of they are not in position to deliver this vision of utility computing in their own right. What we need is convergence, a converged and pervasive platform offering various capabilities such as like for example, it must be ubiquitous, that's very important. Then it must be reliable, so it must offer, for example, it must self-manage by itself, and then it must be dynamically composable, and it must also offer SLAs. For example, if consumers are using certain services, need to make sure that they are offered at a quality at the SLA agreement that one has. SLA stands for Service Level Agreements, which is basically an agreement that is defined through negotiation between provider and consumer. And such a converged platform, so potentially has something like $1 trillion per year business opportunity. And this is a big opportunity. So soon I will give you some data on why I really think so, like $1 trillion opportunity by year 2020, let us say. So having looked at high level, now let's take a look at cloud computing. What is it, and how is it distinct from others? Of course, this is definitely building on previous developments, but it offers few distinct characteristics. So cloud computing is quite popular today. So how do we know that? We can look at various parameters. One of the parameters would be how many people are searching for cloud computing. For example, using search engines such as Google. So this is the data for grid and cloud computing. The reason I gave is often people think cloud computing is the next step of grid computing, and some people think grid computing is like a spiritual precursor of cloud computing. So looking at these two, how many people are searching for these using Google? So you can see here from 2004 up to now. So of course cloud computing term was hardly used there at that time. In 2004, you see it was very large volume of searches were on grid computing. Then up to 2007, you see it's still dominated. In late 2007, cloud computing gained enough currency that it can appear in that graph. So you can see within a few months, so it just took over grid computing, and then massive explosion as a result. And then things such as financial crisis in 2008, global financial crisis, and there were so many problems. Still, people paid huge attention to it. So maybe people were thinking that there's an area where they can work on and get jobs. That's probably what it means actually. Then these are the top 10 reasons from where the search requests are coming from. So the first one is India, followed by Singapore, and Australia is here, and UK is number 10. So essentially, of course, this doesn't mean that the more development or research happening, but what it means is there is a huge interest from people, common people. So then these are the top 10 cities from where the requests are coming from. So Bangalore and Mumbai, Chennai, these are expected. These are quite dominant cities where IT happens in India. And then Singapore and San Francisco and Taiwan at the number 10. So this is how worldwide trend is. Then of course these are the languages in which such requests are made. So Korean, it seems number 1, followed by English and some European languages. Chinese is here, and then Spanish and so on. But you might be wondering, so UK is number 10, and why is English number 2? It should be number something else. So in my opinion, this is not because people from UK are so much interested in cloud computing. It is because people from India. So most educated ones who are working in IT area, probably they use English language rather than national language. So in India, there are so many languages. National language is called Hindi, and there are many regional languages. For example, the place where Bangalore is, there's a language called Kannada. For example, I can speak Kannada language myself, and then there's another place called Chennai, for instance. There they speak different language called Tamil, right? So we have some people here from Tamil state. So if they were searching in those regional or national language, then Hindi or those regional languages would be somewhere here, and English, instead of number 2, it would be something like number 20 or number 30. So it would be, it's big change in IT area. And that is what we are seeing, how the economy is shaping it all in worldwide scenario. Okay, so then here is something else that just released very recently from Gartner. So Gartner every year releases this graph called IT hype cycle of emerging technologies. So according to this graph, this is just released this month only. In 2007, so cloud computing was like a trigger. There's an interest created. Then within year, it moved up very quickly. It was here. Then last August 2009, it was at the peak. It's still this year, it is still at the peak. There's a huge interest worldwide. So for next 1 year, there's a huge interest worldwide in cloud computing. Then according to this graph, so some technologies takes 2 years. Less than 2 years, they come from peak to part of the productivity, and some of them take more. For example, cloud computing expected like within 2 to 5 years, it will move from that peak of expectation to part of productivity, where most people will use this cloud computing very comfortably without worrying about any of those issues that come up against adoption of cloud computing, which we'll discuss soon. So, which is good news. And of course, I think this is also highlighted. If you look at number of proposals that are submitted to ERC this year in cloud computing area, so skyrocketed. So lots of people are have submitted. I mean, this is the right time. In fact, if you want to win a grant from ERC, this is the right time to apply for a grant. Okay. So what is cloud computing? So there are lots of views on what cloud computing is, because this is such a such a peak of expectation. So everybody is hoping that they can find solution for their problem. So as a result, we have got so many definitions for cloud computing, and all of them seems true in a way. So for example, here you will find 20 definitions. Some of them think like cloud computing is all about renting a remote server and using it for hosting some like mail or web or those services. Then some other thing like renting a remote storage, which you can use it for backup purpose, or it can be renting multiple servers. If you have a large workload or an application that need to support large number of consumers or users, you want to make sure that the system is scalable, that can scale as demand increases. So that is also true. So like this, there are multiple views are held on what cloud computing is. And here is my definition for cloud computing. So I guess I tried to be a bit more scientific, and I wanted to embrace that it is the next step in the development of distributed computing. So in my opinion, cloud is a market-oriented distributed computing platform So it is the next step of distributed computing, but characterized specifically by market-oriented. So I don't mean like industry players playing a role here, but what I mean is truly adopting market principles.